Hello, students. My name is Harry Mullen, and I just wanted to let you know that we have a video for you today that is going to coincide with the lesson plan that you're currently doing. So please enjoy.
Hi, my name is Sharon Rojo, one of the clinical education specialists here at Healthmark Industries. Today we're going to go over the McGann installation tester that actually tests for damage on your insulated instrumentation. Our product solution, the McGann installation tester, can help you meet the standards and recommendations for the new ANSI/AAMI ST79 Amendment 2 2020. Under the new Amendment 2, 8.2.1, under inspection of instruments intended to be used with electric current, it states that instrumentation intended for use with electric current should be tested for integrity each time it is processed. Each installation tester may be supplied with a variety of accessories to test specific instrumentation and cables/cords based on their design. Cables and cords are also a source of concern and need to be inspected and checked for integrity and continuity. Also included in the document is a table/list that states laparoscopic, including robotic instrumentation. Methods to assist with inspection/testing are as follows: installation tester, lighted magnification, enhanced inspection microscope, visual inspection, and tactile inspection. Also included in the list is insulated forceps, example bipolar forceps. So what comes in your installation kit? The kit will have the following: the installation base unit, the AC charger, the green grounding wire with the alligator clip, the brush electrode, the LS ring electrode, the tri-hole electrode, the saddle block, the thumb drive with the quick start manuals. You can also go to our website for more information, and your case. Sold separately is the bipolar fixture and the wire testing unit. Before we get started, let's talk about the calibration of the installation tester. It is recommended at least once per year to make sure that the installation tester is calibrated to make sure it's operating at the appropriate voltage. Typically, what you might encounter is that the voltage may not be consistent and may not stay for whatever voltage that you're selecting, and a variety of other issues. Make sure you contact your local sales representative for prices and process. Let's discuss the anatomy of the unit. On the voltage display, the kV right here stands for kilovolts or voltage. This will appear in the display, and when the unit is turned on, it will reflect the last voltage used, like you see here. On the right, below the voltage setting, you will see the LED alarm light, which is visual, and you can actually hear the alarm when a defect is detected. The unit has a rechargeable lithium polymer battery and has a battery LED indicator light that's on the left below the display, stated here, battery. For our US model, if the battery light is green, the battery is fully charged and can operate around 10 hours or up to 1,000 instruments. It can take 2 to 4 hours to fully charge. If the battery light is red, the battery is flat and you will need to recharge the unit. If the battery light is blue, it is charging, and while the unit is charging, you can operate the unit for the US model. Also note that if the unit is turned off and you're charging, this light won't display. For our international model, you'll notice a CE in the front of the installation tester, and you will not be able to use the unit while it's being charged. There'll be a blue flashing light while it's charging until it's fully charged, and it'll be solid blue. On the front bottom of the unit, you're going to see an off button, an on button, and then the up and down arrows to adjust the desired voltage dependent on the accessory being used. On the top of the unit is a red base unit port. This connects to the accessories, the saddle block, and then the red wire for the wire testing accessory. On the bottom is the green grounding port for the use of the green grounding wire and alligator clip. On the bottom as well, you'll see the power supply to connect the adapter to charge the unit. Now that we covered the anatomy of the installation tester, let's walk you through how to use each one of the accessories. Before we get started and you start using the McGann installation tester, it is recommended that you wear gloves. As I walk you through each one of these accessories, each one will have a specific voltage that's recommended through the IFU for the McGann installation tester. The first one here will be a 2.8 voltage, and that'll be the LS ring. The bipolar fixture is going to be a 2.8. The brush electrode is a 3.0 voltage. The tri-hole accessory is going to be a 4.2, and the wire fixture is also going to be a 4.2 voltage. If the voltage is too low, then you may not be able to detect the damage in that type of insulation on an instrument. If the voltage is too high, you could damage the insulation as well, and this is why it's so important to make sure that you're setting the voltage to exactly what the accessory that you're using. The first accessory that we're going to address is called the LS ring. The LS ring is used for laparoscopic instrumentation like you see here. There's two ways that you can actually set this up. The LS ring accessory can attach right to the base unit, or ideally to the saddle block, and place the LS ring unit to the saddle block for two different reasons. One, it's less cumbersome when you're testing, and for safety reasons as well. A good laparoscopic instrument will not alarm between distal and proximal end of the insulated shaft. Now, to begin, we want to make sure that the laparoscopic instrument is grounded. So in the non-insulated part, it should go off. So what you're going to do is once it's grounded, you're going to go in slowly, and you want to make sure that you're going slowly, especially at this distal end here, because as you can hear and you can see by the alarm, it's going off. You want to go slow all the way down the shaft to the proximal end. Then you're going to go all the way slow back to the distal end. And that's how you test a laparoscopic instrument. In this accessory, this one is called the tri-hole accessory. You're going to notice that there's 3 different holes in this accessory. The first one is a 10 millimeter diameter for laparoscopic. The second one in the middle is for 5 millimeter laparoscopic. And the third one is for 3 millimeter laparoscopic. There is two different ways that this can be used. This can go directly into the unit itself, like so, or ideally into the saddle block, like this. You're going to set this voltage setting at 4.2. Because this instrument is 5 millimeter in diameter, you'll be using the middle hole, like you see here, tested to make sure it's grounded. You want to make sure you're going slow. And there's a break in this particular laparoscopic instrument. Go all the way to proximal end, go all the way back slowly to distal, and of course there is a break there, and that's how you test with that accessory. This accessory is called the brush electrode. We're going to be using it today to specifically test an insulated handle on a laparoscopic instrument. You will see throughout the tutorial that will be used in tandem with other accessories when testing. There's 2 different ways that this can be used. This can go directly into the unit itself, like so, or using your red HV wire, you would connect the wire to the unit and the brush electrode to the wire. This specific accessory is set at a 3.0 voltage. Once you have that set, making sure that's securely grounded, you're going to brush, almost like painting, the handle itself. It will go off in the middle because you do have an exposure inside with the metal, which is normal. You will also have it deep inside in here depending on the model. So those 2 areas where the metal is exposed, that is supposed to be there. It's all the places where it's insulated. So you start from the top and you're going to paint it, and you can hear already and see that there's a break. You're going to paint all the way down and you can hear it just arcing completely because there's a lot of mini pinhole breaks. After you paint that part, then you're going to do the parameter here, and you can see it's going off. There's a lot of damage. Then you're going to go in the ring handles itself, then you're going to flip it, and now you're going to paint again, and you can hear there's just numerous breaks in this specific handle. With this accessory, this is called the bipolar fixture. This is used to test your insulated bipolar forceps, like so. There's 2 ways to actually test with this specific accessory. You can put it directly into the unit itself, or into the saddle block into the unit, like so. After you connect the bipolar fixture to the saddle block and the saddle block into the unit, you want to set the voltage at 2.8. Once you got that in place, you want to make sure you get the grounding wire hooked up to the bottom of the base of the unit. The black connector would go after you take off the alligator clip. Place that on there and place your wire electrode onto here like so. Then you're going to take your bipolar insulated forceps and you want to make sure that it's grounded. So you're going to go on the very top here, and the technique is you're going to make an M. You start at the base, you go up the shaft, and each shaft is called a tin. So on this side of the tin you're going to go up, that's normal because that's exposed, all the way down into the middle, up, and as you can hear and you can see there's a break, all the way up, which that's normal, all the way down, there's another break, which is damage, all the way down to the base. You're going to go back, and then you're going to go front, and there's another break of damage there, all the way down. So this accessory here is called a wire testing fixture. This is actually to test the integrity, which would be the outside of your cables and cords. Specifically, your bipolar cords that are reusable and your monopolar reusable cords as well. So you get your suction cups and you're going to put that onto your workstation. You're going to take your red HV wire and you're going to plug it in to one end into your wire fixture and the other end to your unit. This specific setting voltage is 4.2, so we'll set our unit to 4.2. After you have everything hooked up for this wire testing unit, let's talk about a little bit about the unit itself. So you're going to push down this blue handle and you're going to see what I've exposed is 3 different diameters for cables and cords. The first one you're going to see is a little bit thinner, so that's for a single smaller diameter monopolar cord. The middle will be for a bipolar cord, and this last one is for a thicker in diameter monopolar cord as well. One of the key things to remember is when you're grounding. So if you're using a bipolar cord to test, you want to make sure that you ground both of the leads, like so. If you're grounding the monopolar, it's as simple as that by just grounding that one piece. We're going to go ahead and test this bipolar cord. So we want to make sure it's grounded, lay that down, and how you do this is when you're going to pull this down, you're going to find the right area, which is right in the middle for the bipolar, and you want to make sure that you pull this through from distal to proximal, all the way through. I'm going to pull it through, and you can already hear that there's damage in that cord. And then you keep going to the very end. As you saw in this demonstration, the instruments used were damaged, and it's very important that those damaged items are taken out of service. ANSI Amy tells us that each of those insulated devices that are processed need to be tested every time. The McGann installation tester did pick up numerous breaks, and these breaks can actually cause surgical burns in the patient internally and externally, OR fires, as well as burning through the glove of the surgeon. This is why it's really important for our patients to make sure that we're testing. Thank you.